Assalamualaikum warahmatullahi wabarakatuh and good day. So today we will discuss on subtopic 5.2 area between curve. Lesson outcomes. At the end of this lesson, students should be able to sketch the curve for the given function. Use definite integral to find the area between curves. So in these subtopics, we will have two curves or maybe more than two curves where we will have upper curve. Okay, for example, in this figure we have upper curve and also we will have lower curve. Then the area or the region that we want to calculate is actually the area bounded by the upper curve and also the lower curve. For example, in this figure is this area here, so I denote as R region. Means that this region is the area bounded by the upper curve and also the lower curve from the lower limit A until the upper limit B. Let's look at this note. In some practical problems, we need to compute the area between any two curves. Let f as our function such that fx is greater than or equal to gx. In other words, fx is our upper curve and gx is our lower curve on the interval a and b. To find the area of the region between the two curves from x equal to a to x equal to b means that this region R, we subtract the area between the lower curve gx and the x-axis from the area between the upper curve and the x-axis. Theoretically, if we write in mathematical equation about this statement, then we will have this formula. Okay? So, to calculate the area between curves, we will use this formula where the area is equal to the evaluation of your integral of upper curve minus the lower curve from the limit A to B. Let's look at example. Find the area of the shaded region. So let's say in this example, you have two curves. The first curve is the straight line here. Okay, so the first curve given by this straight line, which is y equal to 2x plus 1. Alright, and then we have the second curve, this quadratic curve here or this parabola here, which is y equal to x squared minus 3x plus 5. So based on this figure, we can see that the first graph here is our upper function. Okay, and then the second graph here is the lower curve, means that represented by this lower function. Okay, so how to find the area of this region here? Okay, because we want to calculate the area bounded by these two curves here. Okay, so first we need to have another definition and another information, which is how to calculate the lower limit and how to get the information about the upper limit. So we need to find the lower and upper limits of the integrals by searching for the intersection point. Okay, by calculating the intersection point of these two curves here, then it will give you the information about lower limit and upper limit. So this can be done by solving the simultaneous equation. Okay, so since we have y equal to 2x plus 1 and y equal to x squared minus 3x plus 5, then if we equate between these two, means that I replace my y here with this 2x plus 1, then I will have this equation. Okay, then I rearrange this equation, I simplify this equation, then I will have x squared minus 5x plus 4 equal to 0. Okay, so this is just our quadratic function. Then I factorize this equation here. It will give me that x equal to 1 and 4. Therefore, from here, I get the information about the lower limit, which a equal to 1 and the upper limit b equal to 4. So I get the value x here is equal to 1 and the value here is x equal to 4 by solving this simultaneous equation or by calculating the intersection point of these two curves here. Okay, then after that I can calculate the area of this region by using the formula. Remember, the formula is a equal to integrate from a to b your upper curve minus with your lower curve, and then with respect to the x. Alright, so we have here a equal to integrate from 1 to 4. So this is our upper curve. Okay, this is our upper curve. So we substitute here and then minus our lower curve here. Okay, if I can write, this will represent as fx, and then we represent this as our gx here. Okay, then I have this fx minus this gx respect to x. Then I simplify this, so it gives me negative x squared plus 5x minus 4. Okay, then now I can evaluate this integral. You should have this, and then you substitute the limit, then you simplify. It will give you the total area of this region is equal to 9 over 2 unit square. Let's look at this example. So you asked to find the area of the region that is enclosed between the curve y equal to x squared. So this is y equal to x squared, and the lines y equal to x plus 6. Okay, so you have this and this. So from this figure here, we must to identify which is our upper curve and which is our lower curve. Maksudnya kita kena tengok curve yang mana berada di sebelah atas dan curve yang mana berada di sebelah bawah. So if you look here, then we can see that y equal to x plus 6 is our upper curve. Okay, so I can write this as fx in order to use the formula later. And then y equal to x squared is our lower curve. Then I represent this as my gx. Okay, so where is the area? Where is the area of the region that we need to calculate? Okay, so as I mentioned before, the area is bounded by both curves. Okay, means that this is our region. Okay, given by this cyan color here or blue color here. Okay, but we still need another information, which is what is the value of a and b? What is the value of lower and upper limit before we can calculate the area? So let's find the lower and upper limit first. Okay, so first we find the lower and upper limits. Okay, So we have y equal to x squared and y equal to x plus 6. So if I equate these two, or if I solve this simultaneously, so I can have x squared equal to x plus 6. So rearrange this will give me x squared minus x plus 6 equal to 0. Okay. So this is just quadratic function. Then I can factorize here x and x. Okay. So I have 3, 2. So minus and plus here equal to 0. So we get x equal to 3 and x equal to negative 2. Means that I have the lower limit here, a equal to negative 2, b equal to 3 here. So now we can calculate the area. Find the area of the region. Okay, so by using the formula, a is equal to integrate from the lower limit negative 2 until the upper limit 3. So we have upper function minus lower function. So we have fx minus gx dx. So I should have integrate from negative 2 to 3 x plus 6 minus x squared dx. Okay, so we can straight away evaluate this integral. So I should have x squared over 2 plus 6x minus x cubed over 3. Okay, now let's substitute the upper limit first. And then minus means the value for lower limit. Okay, so if you solve this, you should get 20.8333 unit square. Now let's look at this example. Find the area of the shaded region by the curve y equal to x squared. So I sketch first. Okay, so y equal to x squared, we have concave outward but shifted to above. Then you will have this. Okay, let's say here 2. I just use free sketching. Okay, sorry for bad sketching here. And the lines y equal to negative x. So remember y equal to negative x is something like this. Okay, so here is y equal to x squared plus 2. This one is y equal to negative x. X equal to 0, so somewhere here. Okay, x equal to 0 and x equal to 1. Let's say x equal to 1 here. So we need to find this region here. Okay. So you can refer here. This is the sketching that I done by using Maple. It's more clearer here. Okay, this is just free sketching. So it means that the area of the shaded region that we want to calculate is this one, this arc here. Okay. So as I told you, we must to decide which one is our upper curve. So in this case, this is our upper curve. Okay, so we have fx equal to x squared plus 2. And then this will be our lower curve. So this is our gx, which is negative x. Okay. So to find the arc here, so we use the formula a equal to integrate from lower limit. So in this case, our lower limit is 0 and upper limit is 1. So fx, x squared plus 2, and then we minus with our gx, negative x. Okay, means we want to integrate from 0 to 1, x squared plus 2 plus x dx. Okay, so it's very straightforward, just an algebraic function here. Okay, so now we evaluate this integral, we should get x cubed over 3 plus 2x plus x squared over 2, okay, from the limit 0 to 1. So substitute the limit, so we have 1 cubed over 3 plus 2, 1 plus half here, then everything here is 0, because when we plug in x equal to 0, of course we have everything equal to 0. Alright. So now if you use your calculator, you should get this equal to, so 1 over 3 plus, so 2 is the 6 over 3, and then plus here is the okay, never mind, put the 2 here first. Okay, plus 1 over 2. So if we equate all the denominator, we should have 2 over 6 plus 12 over 6 plus 3 over 6 here. Okay, which will give you 2 plus 12 is 14, plus 3 is 17, should be 17 over 6 unit square. So this is our area of this region.